Well, I'm very glad that we get Damien to come over here. It was like quite tough actually. I had to go all the way to Finland and convince him, and then still have a lot of chats. And then at one point I did convince you to come on over. And then there was another task that was really tough this morning. That was because Damien was a bit drunk yesterday, and sleep was the night before, and I was the one in charge of getting him out of bed. And he lied to me a couple of times and told me he was awake until I actually went down there and actually had a long conversation.
I went awake.
Yeah, sure. But anyway, you got him out in the end, right?
No, he went back. Several times.
Several times? But well, it's, I'm still glad that you're here, and I guess that you're going to do an awesome game. It's a really well. So anyways, I'm going to give the word to you, and thank you.
Now it's awkward.
Okay, so hello. My name is Damien Morello. I used to be a gameplay and graphics programmer at Recoil Games when we worked on the game called Rochard. Some of you may know it, some of you may not. So I'm straight ahead and move to a trailer so that you know what this is all about. The sound works.
This is Big Daddy 427 requesting permission to land.
Big Daddy 427 will clear to land. Hangar 31R. Caution, traffic with IR turbulence. Welcome back, John.
Okay, so now you have a little idea what the game looks like. It's a 2.5D side scroller, which basically means the graphics are 3D, but the gameplay is 2D. And it was made with Unity and developed by Recoil Games, as you may have seen from the video. And the genre is a mix between action, adventure, and puzzle. So Rochard, John Rochard, our hero, that you can see in the logo up there, he's an astro miner, and he is an everyday hero, which means that we didn't want a space marine kind of character, we just wanted a simple miner with his everyday tools, which is the weapon he also how it is on in the logo, and it's called a G-lifter, and is used to manipulate gravity. So I'll get a bit more into the details in a while. So the game was published on PS3 first, and it was the first Unity game on PS3. It was published by Sony Entertainment, and later on came on PC and Mac, self-published by Recoil Games. So it is on Steam PC and on Mac App Store at the moment, and might cover some more platforms in the future. So the development cycle for the game was below 2 years, but the actual production took about a year, a bit more than a year. So it was pretty tight, our schedule, so we had to move quite fast. And we had 20 people working on the project, roughly, and we also gathered a couple of outside help for voice acting, and we got very lucky to get very talented actors such as John St. John, which is the voice of Duke Nukem, which in this game is the voice of John Rochard, and Lani Minella, which has worked on a million game before and has a lot of experience. So we managed to pull off a believable story with very great voice acting. And the game received a very good welcome when it came out, and we won a couple of our awards. Our favorite ones was the Best Graphics and Best Gameplay that we got at the Unity Award last year, and then a bunch of others. I hope we get some more, but we'll see. And so the game was quite welcome by people, but very little I've actually heard of it and how its development went. So I'm gonna go a bit into how the development of Rochard went from the very beginning, where we didn't quite know what we were up to when we started. So as I mentioned, the schedule was quite tight and we needed to get something done quickly. And to actually continue doing it, we needed help from publisher to actually get some funds to get the game start production. So we started to work on a very small demo, which took about 2 months to be done. It was done from scratch, so we did have no idea what technology we would use, what the game would be about, or anything like that. We just decided, let's make a game because it's kind of our job. So we just started that publisher demo that we did within 2 months, and as just mentioned. We did, after a month and a half or so, we did have a gameplay working. We were sort of happy, but it turned out to be a very generic side-scroller. It was, take that trailer, we moved the gravity gun and the gravity, and that's what we had. So it was a bit boring. It looked okay, but that wasn't what we were after. So in bottom line was the game was very boring. So what could we do to make it more interesting? One of the first ideas which popped out was to create a weapon which would allow us to grab and throw objects around. Well, that sounds fun, right? So why not try it? So we started from this, and we ended up very excited about it. And unfortunately, after playing with it for a while, it became boring again because that just wasn't enough. So we started about controlling the gravity as well, which we added secondly. And now it became cool and entertaining, so it wouldn't get old as quickly because you could control trajectory of the object you would throw by manipulating gravity on the fly. And it became actually very interesting mechanic to build our core gameplay on. And the problem is it was a good idea, but it wasn't a game. So we needed to prototype a massive amount of features to make it more interesting in a very short amount of time. That's where Unity turned out to be great. We, of course, started to use Unity after evaluating it at the very beginning. And our motivation mainly behind it was the workflow was insanely fast. We could just prototype things in a couple of hours, which would have maybe taken like days to do on some other tech. So we started from there to make a lot of features. So Rochard was not a game by design, so to speak, so we did not have any design document when we started. Just a few ideas, and a designer, of course, dedicated to it, but he was just starting and nothing, it was all fresh. So the teamwork is pretty much what built Rochard. By teamwork, I mean that a lot of the features that you've seen in the trailer and some more I will show later, they just came up from ideas people had. So we just knew the core mechanics that I listed in the previous slide, and we just tried to build whatever we felt like could belong to the game. So we were about 20 people and everybody participated. So programmers could do certain programming tasks, and the artists would actually use all the components that we had provided in the past to win some crazy ideas. And even with that programming knowledge, Unity allowed us to let artists and designers prototype some gameplay mechanics. So it was actually very funny. So the no gravity, for example, which is not in the game, was one of the first ideas we tried. How about not having any gravity when we toggle it off, and use the weapon to shoot backward and propulse yourself in different directions, so you can actually navigate in the level like this. Sounded extremely fun, but it really didn't work out. It was really awkward to shoot backward. It was unintuitive, and nobody actually managed to do anything with it, so we dropped it. The recoil jump is one of those which made it so it's when you grab an object, go in low gravity and jump and then shoot the object while you're in the air in the opposite direction you're going to. You will get a kick to jump a little higher than what you originally planned. And that helped us to do quite a lot of navigation puzzles and variation of it. So it was actually one of the features which we kept. Mines was a very funny thing because we blew a lot of things up during this time where we tried different things. And mines were great, but they weren't really making justice to the coolness of the explosion, so they were also dropped. Because it just wasn't that fun. It was just frustrating to keep stepping on one because you couldn't see them from the camera distance and all that. And we couldn't find a good visual cue to tell the user that there's mine there without spoiling the fact that the mine should be a surprise. So they were dropped. And early on we also had a jetpack because why not? And that was dropped as well because it was not originally nice and it didn't really fit the core ideas. However, because we had a designer, he also did a bit of work on his own, and a pretty good one, I have to say. And so a lot of the features that were in the growing GDD made it into the game exactly as designed. But because we kind of got that rhythm to go wild with some of the features, even the features which were designed, we tried to make something more out of them. And a very great example is the grenades. By design, we were supposed to have just a standard grenade. You shoot a grenade, ballistic projectile, which fall on the floor, blow up, and that's it. But we turned that into a sticky grenade, where you can just shoot the grenade, and it will stick to whatever surface it hits first. So it was really fun to actually try to sneak in and throw a grenade on one of the enemy, make him wait for him to go through his guard cycle, go closer to another character, and blow the whole thing at this point. So the sticky grenades made it to the game because they were actually fun, and the level designers found a great usage point where you actually need to stick grenades on moving objects to reach points you cannot reach otherwise. So it turned out to be a great feature. And from sticky grenade, but something sticky, we were like, what other kind of grenade could be sticky because it seemed to be fun. And anti-gravity grenade was another thing which ended up in the game. You just shoot a grenade on an object and it will remove gravity from this object, so you can actually move it very easily. And by changing the gravity, it will also cause the object to go up. So you could sort of create lift after a certain object with that feature. And it became interesting. And these two were not really designed, but the designer loved them. So out of all these things we tried, not everything succeeded, and it was a very tough time for the designer because there were millions of good ideas, but a lot of them would have to be dropped, and we had to be very careful that the ones which remained were loyal to the core idea of the game. And one of the biggest problems is at that point we were already in the middle of production, and it's not a good idea to make massive change that late in the development. But it sort of worked for us, so I'm not gonna say it's a bad thing. So some very cool stuff did not support the mechanic, the game mechanic, and this would be an example. The black hole grenade was very fun. It just creates a black hole, sucks everything in, and blow it up. Very simple, very powerful, and it also looked pretty good. So we were like, hey, this is the best thing ever, we're definitely going to put it in the game. And we realized that, first of all, this was a way too powerful weapon. That wasn't interesting, because you just could use it whenever you can, and it kind of was too powerful. And on top of that, because you would use it so much, it's such a slow weapon to react, and you shoot it in front of you always because you try to keep the path to go through. It kind of broke the idea of having a fast-paced game to where you keep moving forward. And what happened is you actually had to go backward because otherwise you would be sucked in the black hole. And we tried to tweak the power of the thing, but when it was less powerful, it wasn't impressive anymore. So we kind of dropped it as a player feature, but we turned it into the big boss, the final battle. It's a big boss weapon, and he used it against you. So we still had the weapon, the weapon type in, but had a completely different meaning. So at this point, as I said, we went really well, so some even cooler shots than that actually just didn't make any sense. Just as at one point John was shooting stars from his gun and rainbows from his rear. It obviously didn't really fit the core concept of the game, and we did drop that feature as well. But it was very fun to see, and I hope we get to make a game based on that at some point. So another interesting thing that some people might argue with is some of the features which were really cool, the breakable glasses. For example, in the game you can break glass to access hidden places, and you can also use glass to protect yourself from enemies' bullets. Well, the designer really wanted them in, but the producer was like, no way, we're already late. And so what we did was just put them there and not really tell him. And he wasn't happy when he realized that, but it was too late because it would have taken more time to remove them. So we just ended up keeping them in the game, and we were all pretty happy except him. And I think it was a good choice from us because we've gotten good feedback about those features we sneaked in that the producer didn't want. So sometimes it's good to act on your own. And other features were completely by accident, like one of the major success in the game. The G-swing became one of the core mechanics in the game. It's when Rochard uses his weapon to lift himself up on an object, and he can kind of do Tarzan stuff with that. And that started from a complete accident. For people who know Unity at all, there is a component called rigid body, which turns pretty much any object into a physics object. And there is a checkbox which says if the object is kinematic or not. If you check it, the object will become static. It still remains a physics object, but no physics are applied to it. So all the boxes we have are rigid bodies with a checkbox left out. The thing is, one day one of the programmers actually forgot, was just messing around on his computer, and he forgot to uncheck that box, and the designer walked behind him. And the programmer grabbed the box, and it suddenly got lift to it, and Rochard took a swing at the box. And it looked really cool. The designer stopped, and he looked at the screen and was like, what the hell? This is the coolest shit I've ever seen. And immediately after that, we started to work on the feature properly, and it got into the game. And that was, I think, a very good example on how anybody's creativity can contribute to a game. So what you can learn about that is Rochard is a textbook example of a team effort where everybody was very talented and very devoted to the project. So everybody really tried to make the best out of what they had. And Unity in this situation pretty much gave us a means to make it happen. I hear there is Unity licenses during the game jam for people, so I highly recommend you guys to actually go with that because you will save a lot of time. So, but anyway, that's pretty much it for how it started from a design point of view. And I'm gonna show you one more trailer, which, yeah. And after that, I will go a bit into how we implemented some of the feature in the engine from a high-level point of view, and how we achieved the look that we were after in the game. which shows a bit more than the first trailer. So now some of these features I will try to explain now. So on the gameplay elements, we built the characters so that there would be pawns and controllers. So the pawns were the actual character, and the controllers would be something driving it. It could be an actual physical controller, then the keyboard, mouse, gamepad, and or an AI controller, which would then be just driven by the AI in the game. So the way we did it was to store all the input in a separate place, and we would just simulate input from the AI, which worked quite well because we could actually record also some sequence and play them back just by reading that string. So it was a very good way that worked for us. And then the pawn, which could be hit and take damage, had a specific component added to them, which were hittable objects, and they would be responsible to show all the damage. So as you can see, all the particle effects when you get hurt or when somebody else does, were actually built around this system. The movement controller is how Rochard actually moves and how other characters also move. We started out of making a huge class which would contain all the physics modes for the character. So it could walk, crouch, jump, run, as the G-swing, of course, and all the different modes, use an object, anything which plays an animation. And it becomes really difficult to read from a programming point of view, and we had a lot of problems with that. So we decided to split the movement abilities of the character based on what movements they would do. So it's not entirely atomic, but it's much closer to being atomic than the original aspect, which was just big chunk of code which became unreliable. So we split by animation and by physics movement. So anything which affected the physics would go in certain movement, and you can see from the slide, walk, run, were different movements. Ragdoll was a movement in itself because the entire body became physics. So and we had a movement controller which would switch between these components when needed. So this, you probably can't see much, but that doesn't matter. You could maybe get the slides later. The idea is that this is the same component that I have stuck together, and for people who use Unity, does anybody understand what's going on there, or do I need to explain something more? Yeah, I need to explain something more. So in Unity, you drag and drop components for to enable a certain feature on a certain object. So this is the inspector view, so it's a big list of components that shows what is available. And for each of them, you can not really see actually, but we have a lot of components in there, which are split from what I showed in the previous slide, the aim, the jump, and so on. So I'll put that available somewhere after the presentation if you're interested, because you really can't see anything from there, unfortunately. So let's move on. The weapons, they were done out of weapon attachment because we never really knew what kind of weapon would end up in the end. So we built it so that we would not have a very static system. The weapon was doing nothing, it was just a visual mesh, but we attached a lot of components to it, which created the flashlight, the aiming laser, and the actual barrels for shooting the lasers, the kind of beam, like the gravity beam, and the grenade as well, and the projectiles, which were just normal ballistic projectiles. So it was done in a dynamic way, and it was very helpful to prototype many variation of weapons. So earlier I was talking about that black hole grenade that we dropped from the player and moved to a character. We just had to drag and drop the actual object from Rochard weapon to the enemy weapon and press play, and that was done. So it was a very minor switch, and we were able to try out many different things thanks to that. Then the physics, I had to make our custom character controller so that the character would react to the world, and the world react to the character as well. So it was a side scroller, and the gameplay was in 2D, so it was not so much of work. And it turned out that we were able to create very interesting physics puzzles. So sometimes you have to move a swing, and when working on it, throw some boxes on the other side to get an impulse. So it was very good to build the very standard physics puzzles that you see in many games, but also be a bit more creative on those. And the low gravity allowed us to even push those puzzles to a bit further level. And then the core routines in Unity is a routine that is a function you can suspend at any point. And it was extremely useful for us because the level flow is done by code. And the level designers, which did not have a programming background, were the ones doing it. So they needed a good way to script what happens in the level, but a very simple way at the same time. So we just explained to them very quickly how our code works, and we gave them an API, a very simple one, to be able to listen to events and broadcast events so that triggers would react to what was happening in the world. This turned out to be extremely successful because our level designers, which really weren't even interested in doing programming, got quite excited and came up with very interesting mechanics using the features they had. And that we didn't even think of. So that was a good system. And the AI was built on the same system through coroutines so that the functions would just run in the background. And so the shooting and firing and aiming at the target was done in the same way with coroutines. So on the game framework point of view, the loading scene was something which was a bit difficult to do at one point. We had a requirement when we were working on the PS3 that we could not have the scene frozen for more than 1 second, and when loading a new scene it would actually take a long time. So Unity introduced in 3.0 level streaming that we started to use, and we additively loaded the new level on top of the previous one. And the previous one would be the loading scene. So we could have an animation playing in the background, loading happening. So in the end, there were no stall of more than 1 second, and passed the technical requirement checklist from Sony, thanks to that. And then we also needed a lot of helper methods, because Unity provides a lot of those, but we needed a lot more because we built our own system on top of it. So what we did was to inherit the monobehavior, which is the base class of our Unity functions. And we just started to implement all the helpers we needed from there. And each of our components inherits from that class, which allowed us to cache certain data and optimize at some extent thanks to that. And persistent data and code game manager, we got away by using the resource folder in Unity, which allows to load data which are not referenced in the scene. And but that's just to understand games and things like that. So from one level to another, we would actually have certain data which would be maintained. We would try to progress as a user and be able to restore it if needed. And finally, from a performance point of view, we built a room system which was both for logical and graphic optimization. So when Rochard was in a subsection of the map, only that subsection would actually be visible and all the other section would be hidden. It was a lot of work, but it did make the game run much faster on the PS3, so it was a good move as well. And I'm going to go through some of the tools we developed within Unity to actually use that room system, and you will see about that very soon. So about the editor tools, we created a lot of them. Let's go through them already. Level building tool was created to ensure that the map would have all the required elements. So some game objects must be there for the AI and everything to work, like even the graphics the post-processing was stored into something which must be in the scene. So we had some tools which would ensure that a level designer would not forget to place a very important object in there. Then we extended the Unity Ragdoll wizard so that it would automatically generate a ragdoll for different type of character without having to manually feed the input every time. And we developed a graphics tool which allows to simulate the camera movement in the editor of what it would be in the game. So it was, I hope it's really blurry here, but anyway, this is the graphics tool, which is a very small little window, and by putting a checkbox, you were able to get the camera to move at the same time. You would edit a section of the level to define if the camera was supposed to be constrained so that it could not start going out of the level and show some places that you are not supposed to see, which are represented by that kind of line box looking thingy. That's the camera area, and by editing those, in the game preview, you could immediately see where the camera will be standing when you play the game. So this was extremely time saver for the level designer. Then level tools, we created a little tool which listed all the levels we have in the game, and we could switch immediately between them. And we could also take all the lighting information from this map, so we didn't have to do it map by map. I think it took like 13 hours to make all the level, or 18, something like that. So we had to run it at the night, press build, and come back in the morning and get the result then. The LD tool was one more tool where the level designer would just drag and drop all the items they use constantly in the level, so that they wouldn't have to search from the thousands of assets we had, and they could share this list in between designers, so that they could work with the same set in the same areas, so the graphics would remain consistent. The room tool, that's what I was talking about earlier. You can see from here, this is an entire level in the background, and we have 8 separate rooms that we could just toggle on the fly so that they wouldn't have to wander and update all the time. And that tool was developed so that artists and level designers would place all the objects where they belong in the correct room so that everything would be hidden or shown accordingly. Then the handcuff tool was also another thing which, once again, very blurred. The green text here gives information on what kind of spawning point it is. So here it says that it will spawn an enemy of type Marauder, and its idle area behavior will be patrol, and it will also say alert and fire behavior. So it was really easy to visualize from very far where in the levels would things start happening. So the tool was developed in order to be able to polish the flow of the level, and I think that kind of worked. I hope. And then about the graphics, we had we developed a big set of components for artists to use on top of the ones which were provided by Unity at the first place. So animated textures, trail effects, for example, we had to do quite a lot, and components which affect colors and material settings were also very important because, for example, when you get close to an object in Rochard and this object can be used, then there is a little icon which fades on top of it, which is in world coordinate and says which key you should use on the keyboard or which gamepad button you should use. And so this was actually done by the artists as programmers. We didn't have to worry about that. We just gave them a component that fades the alpha channel based on the distance, and the artist started to go wild and make it work. So that was quite nice for us. And in Unity, you have both forward and deferred lighting. Rochard uses deferred lighting for performance reasons because there are quite a lot of dynamic lights. So we had to make sure it runs on PS3. And the static lighting is done with a Beast light mapper, which is also provided by Unity and generates static lighting information. for the graphic style of Rochard, we tried to go quite stylized. It wasn't supposed to be photorealistic, and we needed to find a proper shading model for the character so that he wouldn't go completely dark in dark areas, because we had to be able to pop, he had to pop up on screen all the time, and we were able to know where we are in the level very quickly. So we used a feature which I think originally was implemented in ZBrush, which is called material capture. And these two images you see here are hand-printed. They are 2D images altered in Photoshop or whatever 2D software you want to use to find. And you do just draw what kind of shading you want for your character. So you can bake some specular, you can make some rim light out of it, you can pretty much do anything. You could even do some reflection if you wanted to, if you have higher enhanced resolution. And we use this to shade all the characters, and only the characters, because they are the ones we wanted to pop. So I'm actually running slow time, so I'm going to go very quickly through that and show you the result afterward. We use different material capture for clothes and skin, and we combine them with dynamic lighting, because we had a lot of dynamic lights as well, and we had to make sure the characters get their constant lighting, their lighting rig properly done, but they also have to react to dynamic lightings. And nowadays there are light props in Unity which sort of covers this, but back then we didn't have them. So what happened is that Rochard was rendered like this, and here you can see on the sphere what the texture would have looked like. So this is just a diffuse texture. This is how the madcap looks when using one of the textures I showed you earlier. And when combining the two of them, you get the lighting rate, which is camera dependent. So this lighting is valid no matter where you are in the world, no matter where the camera is, you will always get this consistent lighting on the character. Then we have the dynamic lighting, which is really dark in here, but anyway. And combined, it will give you the Rochard characters that we used into the game. We use that for the enemies as well, and all organic kind of, and all gameplay kind of materials. Then for the fog sheets, we use them a lot. It's just a mask texture, which allows you to fake fog in a specific region on the map. We had 3 different versions of it. I'm going to show it on a picture. On the background, you can see that very foggish atmospheric effect. It's done just with planes, which were placed by artists. And the shaft of light, you can see up left at the top, was also done based on the same system. And we faked a lot of effects thanks to that. All light shafts were done with just planes, which were, because we were in 2D, so it helped a lot. And a lot of these planes are very close to the camera, so it could be when you change, when you move forward in the level, the camera intersects with that plane and causes some popping. So we made a immediate variation of the fog sheets so that we would have a very cheap one, which would be placed where we know there are no collisions happening, so they would be placed in a very open space. Then we had 2 other variations which were a bit more expensive, one which would fade from the camera distance and the angle to which the light appears. And the camera appears, sorry. And the last one, which uses what they call soft particles in Unity, which will sample the depth at the location of the pixel being rendered. And if it's really close to a surface, it will fade away, so that you don't end up having a very sharp line when the plane intersects with geometry. And it works really well. And you can see it from the walls on the side, that you don't have a very clear line where it stops. And finally, the contact shadows was something very important for the gameplay, because we noticed when playing, Rochard was flying, even if he was actually placed on the floor, because there were no proper shadow information that we could see. It looked like he was flying, and it was very difficult to know where you were actually in the world, and you couldn't really shoot or jump on platforms because you had no idea where they were. So we came up with a solution to create a blobby shadow under the character, which is done as a full screen, as a post-process effect, but done on local areas. So what we did was to render a plane, just quad on the feet and the lower body of each character. And we would place some game objects which were just helpers, which would specify the location of scenes which would contribute to the shadows. So we had one helper somewhere like around the hips, and then we had two at the feet and some at the knees. And what it ended up doing is that this is a version with the plane before compositing. So this is what we got. And there again, it's so dark you can't actually see it from here. But anyway, you can see how it was. Those shadows were generated from sample points in the character. And they were very blobby and fitting the style that we were after. So we put them in for the character and the boxes and the grabbable object, because everything which mattered in the gameplay needed to be in a very easy to spot location in the world. So, and then I will show you how all the things turn out. So yes, that was the end of my presentation. If you have any question or if you want to contact me, I have a slide which says to do it. So, but my time is almost up. Maybe we have time for a few questions, one or two questions. If you have any questions, shoot ahead. And so, any question at all? Yes?
How did you find working on platform like the PS3, where you're the first game coming out on Unity?
It was a lot of work. The question was, how did we work on Unity being the first ones on PS3 platform? So the answer is that it went pretty smoothly. The development was on PS3 was done at the same time that we actually worked on the game. So Unity made it work in parallel with the project. And we worked very close with them to give them feedback on performance and problems, bugs and so on. And they fixed all the things on their hands, and we changed all the things we needed on our hands to make it work. So for a long time, performances were the biggest problem, but ultimately it's just worked just fine. So. Yes?
Did you get paid by Sony Online Entertainment, or did you work out of your own pocket, or how did that work?
Because all the game went on PS3, we had a deal that it was exclusive for some time, and they financed part of the project, but not the entire project, and we financed the rest from our own home. So, and the PC and Mac version did not involve Sony. It was like more indie style in that sense. Anything else? I guess not. Then, thank you very much. Enjoy the game jam and do awesome games. So.